Good morning, guys. I'm going to show you how to do a couple of these problems that was on our quiz. Okay, the exponential functions quiz. All right. I want you to take out a piece of paper and jot down and write some things on this white piece of paper. And then, if you have questions about anything, please make sure that you post those questions on our online Power Learning page where it says, do you have any questions or concerns, okay? All right, I don't have a whole lot of time, so let's get with it. All right, here it says, Mrs. Hayne buys a house for $150,000. The value of the house is expected to increase, that's a key word right there, at a rate, and this is our rate, that's our percent, every year, 10% every year. Which of these graphs represents that? Well, first of all, the starting amount, okay, on my paper, this is an exponential growth because it is increasing at a percent. That's what makes it an exponential growth, the fact that it increases at a percent, okay? All right, so the formula that we're looking at, since it's increasing at a percent every year, is, okay, or T or X, all right? Okay, so we're just looking for the graph. We're not looking to write an equation. We're just looking for the graph. So your C, or your starting amount, is going to be 150,000, okay? So we're going to look for that, and we're going to look for exponential growth. All right, so let's look at A. The starting amount is right. Do you see that? But it's going down. The line is going down. That is not growth, okay? The starting amount is right here at 150, and it's a curve, and it's going up. So this is a possibility right here, okay? Possibility. This looks like an exponential growth. Remember, it's going to be a curve with exponential functions. It's not going to be a straight line because that would be a linear function. We'll look at C. The starting amount is, you see, this is the starting amount, but it's a straight line going down. So two things against it. It's a straight line and it's going down. Here, this is a straight line going up. That's a linear function. So our best answer here, and on our white paper, we're going to put the answer is B. All right. Box in, and let's move to number 2. All right. Number 2. The population of bacteria after X number of hours is modeled by the expression, and this is the expression right here. Okay. What is the rate of growth? Because we know it's exponential growth because what? B is greater than 1. Since B is greater than 1, then this is definitely an exponential growth, okay? All right. And X is an exponent, so we know it's not linear, it's exponential, all right? All right, so here we go. So we're finding the rate of growth, so we want to use the growth percent formula, okay? So that's B is equal to 1 plus R. Your B, your common ratio, remember, is in the parentheses right here. So we're going to replace B with 1.25, and we're going to solve for R. So in order to solve for R here, we're going to subtract 1 on both sides, and this is going to give us 25 hundredths. So R is equal to 0.25, or we write it as a percent, which is going to be, move the decimal over 2 times to the right, that's 25%. Okay, 25% is A. We're going to put A on our paper. All right. Number 3, the population of a city after X years is modeled by the equation. This is the equation right here. Okay, what does this 20 mean? Remember, this is an exponential growth equation. So remember, when it's an exponential function, even in general, this is the formula. This is the exponential form right here. Well, your A is going to be your starting amount, okay, or initial value. And your B is your common ratio, the number that's being multiplied to get to the next number, okay? Remember, if it's exponential growth, your b is going to be greater than 1. If it's exponential decay, this b or this number right here is going to be less than 1. All right? Okay, so the number that this is right here, this is going to be our a. So that's our initial value. So this is going to be our initial population. It says the initial population is 110. That's not 110. Okay. The initial population is 20,000. That's going to be our answer. So number 3 is going to be B. Don't forget to double check your answers. We know that it's asking for what the 20,000 is. This is giving us a percent. This is giving us a percent. Both of those are wrong. All right, number 4. Lindsay makes an initial deposit, okay, initial deposit, that's the starting deposit, of $500 in an account that earns 3.55% or 3 5/55% interest annually. After X years, Lindsay makes a second deposit of $250. $250. Which function below models Lindsay's account balance immediately after she makes that second deposit? All right, so here, we know that this is going to be an exponential growth function because it's growing by this percent, okay? So our exponential growth formula is that we're going to use is C is equal to 1 plus R to the X or T power. Now, we are using this equation because interest is only being charged once a year. So we're not going to use compound interest. We're going to use this formula here. All right. So our starting amount, it says, was that $500. So that's going to be my C. 1 plus, and our rate, it says, was 3.55, okay? So we have to write 3.55 as a decimal, okay? The percent as a decimal. So that means we move the decimal over 2 times to the left, okay? All right, so this is going to give me 0.0355. So I'm going to write this here, 0.0355. Raise that to the X or the T power, doesn't matter, okay? Now, after the second, the second deposit, she added $250 to her account. So that means that she's just going to add $250. Okay, and so this is going to be the answer there. So the answer is going to be B. And this is number 4. Okay? Number 5. Let's look at number 5. All right. Each figure in the pattern below is made up of squares. All right. So figure 1 has 3 squares. Figure 2 has 1, 2, 3, 4, 5, 6 squares. Figure 3 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares. We are to write an explicit formula. That's an equation, okay? This type of equation is where you can plug in a single term or value that you're looking for. If you're looking for the 5th term, then you should be able to plug in 5 and get your answer, okay? All right, so we've got to figure out which one of these equations, if I were to plug in 1, I should be able to get 3. If I was to plug in 2, I should be able to get 6. If I was to plug in 3, I should be able to get 12. So let's look at what that looks like, okay? So for number 5, that looks like this, where you have, let's say, your X value, your figure number, and your Y, your output, which is the number of squares. Okay, so you have your figure number and your output, which is going to be number of squares. So your figure number and figure number 1, you have 3. And figure number 2, you have 6. And in figure number 3, you have 12. Well, look, guys. Miss Reyes. Sorry, y'all. So look at this. So, guys, look. It's going, the common ratio is going to be 2 because you're multiplying. That looks like an addition, doesn't it? You're multiplying 2 to get to the very next number. So we know our common ratio is going to be 2. We need to figure out, however, what our starting amount is. Since this is a generic, exponential function, remember the form that we use for exponential function is this, okay? We know what B is. We need to figure out what A is. What is the starting amount of squares? So let's work backwards because we know the first one, but we don't know the 0, the starting one, okay? Because that's not shown in this figure. So we want to work backwards. Instead of multiplying to get to the next number, we're going to divide to go backwards. So we take this last one, 3, and we're going to divide it by 2, and that's going to give us 1.5. So our starting, or our A, is going to be that 1.5. So that's y is equal to 1.5 times 2 to the x power, okay? 1.5 times 2 to the x power. Sorry about that, y'all. Do you see what I did where I divided to get the starting figure? Because it gave us the first figure, but it didn't give us the starting figure. So this is the equation that we're looking for, and that equation is going to be C. Okay, you see that? That equation is going to be C. Number 6. Okay. Sorry, y'all. Excuse me. The function, and this is the equation right here, 5,500, and then this is my B right here, models the value of a car. And we talked about cars depreciating in value as soon as they leave the lot. Remember we talked about that? After the car was purchased. So we know that this is exponential decay because B is less than 1. All right, what is the appropriate domain? Your domain is going to be your x values, okay? So let me draw my line. Okay, so let me draw my line here. So your domain is going to be the x values that make sense. When it says appropriate or practical domain, it's asking you for what x values actually make sense as it pertains to the problem. Well, X represents the year, so we're talking about the years after you purchased the car. So you can't go, X can't be a negative because you didn't purchase the car then. It's not negative years that you purchased that car. You didn't purchase it. So your starting year is going to be that 0 year. Okay, so you're starting at 0, the year that you purchased that car, and you move forward. So that means you're looking for where X is going to be either greater than, well, X is greater than 0, or it can be equal to 0. So we got to find that answer, all right? So this is greater than 0, but the years can be that starting year equal to, so this is not an answer. X is greater than or equal to 0. This is going to be your answer here, B, okay? All right. Number 7. The table below contains data from a study done on fungal growth. Yuck. The fungal spores were studied over a period of time. So this is going to be my table here. And I'm going to notice the change that's going on. And the second month is 900, the third is 2,700, and the fourth is 8,100. Based on the table, what is the initial number of spores? So let's see what it's going, what this is actually going up by. This is exponential growth because you're multiplying to get to that next number. Now, what is it that you're actually multiplying to get to the next number? If you don't know that, then just divide it and see, work backwards to see what that number is. So we got 20, this is just if you can't see it, and this is what this calculating active is, 2,700. Guys, look, 9 and 3, we know that's going to be 3, okay? We know. So we're multiplying by 3 every single time, okay? Because you look at 9, you look at 27, you look at 81. You can see how that's actually going up. So let's work backwards. If you're multiplying by 3 this way, you're going to divide by 3 going in the other way. So when I divide this by 3, what do I get? 900. Excuse me, I've really got to tickle my throat. Excuse me. So, so here, when I divide by 3, which one of these is it that going to be? That's going to be that 300. Okay, that's going to be that 300. All right. No, wait a minute. Miss Reyes, what did you do? What did I do? I did something. Let's table it and come back because I'm not thinking clearly right now. In 2001, we have the people that attended the public concert. The attendance at the annual decreased by 3% each year since. Okay, so decrease means this is exponential decay. All right, so exponential decay formula, number 8, is C parentheses 1 minus R to the X or to the T power, okay? Where C is your starting amount and R is going to be your percent, okay, written as a decimal. So my starting amount is going to be that, it's going to be this number here, minus, and remember 3%, you have to write it as a decimal by moving the decimal over twice. So that's going to be 0.03, okay, to the X power. All right. Okay, so when I do that, when I subtract that in the middle, the answer there is going to be this one here, B. Do you see that? This is going to be Y is equal to, when I subtract, this is going to be 0.97 to the X power, and that's going to be letter choice B. Okay, got it? All right, so let's do number 9. Okay, so for number 9, a sequence is defined by the equations. Your starting number is 6, and this is your equation here. All right, so let's look at it. We want to know what the 5th term is in that sequence. All right, if we look closely at this equation to see what's actually going on and what kind of, is this linear, is it exponential, is it a quadratic? Basically, when you're doing problems like this, it's only either going to be linear or exponential, because with the quadratic, it goes up and then comes down, or it goes down and then goes back up. Okay, so the only type of functions that you will be using for these type of patterns is going to be either it's going to go straight up, straight down, or it's going to curve up or curve down, but not, you won't be finding the nth term for a quadratic function. All right, so let's look at number 9. Here, with this equation, and this is a sub n is equal to 2, and then it's times, because it's 2 right directly beside a sub n minus your 1, okay? N minus 1, sorry. N minus 1. So my starting amount is going to be, let's see, my first number is going to be 6. So that's not my starting amount. That's my a sub 1. My first number is equal to 6. And my common ratio, my B, I know is 2. Okay, so this is what I know. But what I don't know is the initial value, my starting number. Well, if this is my first number, to go backwards to get that actual starting number, which is that a sub 0, the initial value, instead of multiplying to get to the next number, if we're working backwards to find that initial number, we got to divide. So when we divide, we're going to get 3 here, okay? Because when I divide this by 2, I get 3. So the starting number is going to be 3, okay? The starting number is going to be 3. All right. So that means my equation is going to be y is equal to 3, the starting number, times 2 to the x power. Remember that remember that the exponential formula that you use is this. So A, my starting amount is 3. B, my common ratio is 2. The term that I am looking for is going to be the fifth term. So I'm going to plug in 5. Okay, I'm going to plug in. Sorry, I'm going to plug in 5. So I get y. I get 3 times 2 to the 5th power. So that means I have 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Okay, so this is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, and times 2, which is 32. Okay? All right, and so now we're going to say 32 times 3. So we have 6 here and 9 here. So that's going to be 96. So 96 is D. All right. 96 is D. Okay, y'all see that? All right, so let's look at number 10. I have to make 2 videos instead of just one because my time is running near. All right, so we have 24 m to the negative 2, and we got n to the 4th. Then we got divided by 16 m to the 3rd, n to the negative 5, and we are going to go. All right, I hope I have enough space because y'all know how I write. All right, really, really big. All right, so we're going to take this one step at a time. This is a more complex problem. Let me make sure that those numbers are actually right because they were so small. They were so small when I printed it. So I'm just going to make sure that it's right. And they are. Okay. So the first thing that we're going to do is work in the inner parentheses, okay? Ignore this. Keep bringing this down, but ignore this for right now. Let's just work on simplifying what's in the parentheses first, okay? We're going to break it down. So first thing that we're going to do is look at these numbers right here, and let's reduce this fraction. So in order to reduce this fraction, we reduce this. We can reduce it by dividing both the top and the bottom by 8. Okay, we divide both the top and the bottom, just looking at the numbers, by 8. So that's going to give us 3 here, and that's going to give us 2 here, okay? So we just did the fraction part only, this part only, okay? Now we're going to do this. When you divide like bases, okay, when you divide exponents with like bases, you can subtract the exponents. So this is going to be m negative 2 minus 3, okay? Do the same thing here. N 4 minus a negative 5, okay? Bring everything else down. That's what we have so far. All right, so now, I'm going to slide this up a little bit. So now we're still working this out. This is going to be 3, 2, and this is going to be here plus a negative, so that's going to be m to the negative 5, okay? And in here, plus a positive, so this is going to be n to the 9th, and bring everything else down, all right? Bring everything else down. I'm going to have to go this way, okay, because I ran out of space going that way, all right? So let's look at that. Okay, so now what we want to be able to do is now we're looking at this. It's a negative exponent. Remember, we can't have a negative exponent. To make this a positive exponent, we bring this down to the bottom of a fraction, okay? All right, so this is what this is going to look like. We have 1 over what was in this parentheses before, 3 over 2m to the negative 5. Well, actually, I should have went on and fixed this part here. I should have went on and fixed this, and I could have just said 3 over 2 to make this a positive exponent. Bring this down to the bottom of the fraction. So now it's going to be m to the positive 5, and leave this on the top, n to the 9th. I could have did that first. I should have did that first. So let me fix this right here, guys. All right. So this is going to be 3 over 2. Then we have n to the 9th. And we have m to the 5th. Raise this now to the positive 2. All right, so now this negative exponent is now a positive exponent, okay? All right, so now let's rewrite this so that this doesn't look like a complex fraction. This is going to be 1 divided by, and you have, well, I can go ahead and multiply each of these. This is a power of a power, so we can multiply this 2 times all of the exponents that are here. So this exponent is automatically on that 3. Remember, it is a 1. So this is 3 times, 1 times 2, which is going to be 3. So this is 3 to the 3rd power. 3 to the 3rd power. And this is going to be 9 times 2, which is 18. Okay. And then we got the exponent on this 2 is automatically 1, so this is going to be 2 to the 2nd power. 2 to the 2nd power. And then this 5, you multiply it times 2, so that's going to be m to the 10th power. There we go. Okay. All right. So now we have 3 times 3, which is 9, times another 3, which is 27. So I'm going to put 27 in this place. 2 times 2, which is 4. So I'm going to put 4. Well, I'm going to put 4 and it's 20. What did I mess up somewhere? Why did I say 2? Lord have mercy. Y'all let me do it. Same as Reyes, you are crazy. 3 times 3. Why did I do 3 to the 3rd power? Who knows why I did that, y'all? Who knows why I did that? All right. Russian, that's what. Please take your time. Don't do what I'm doing and trying to get everything complete. Please take your time. All right. So now when you divide here, guys, when you divide a fraction here, you're going to multiply by the reciprocal. So this is 1 over 1. I made this. The reciprocal of this, remember, flip it. The numerator becomes the denominator, and the denominator becomes the numerator. So this is going to give you 4m to the 10th power and 9n to the 18th. Okay? So when you multiply straight across, that's just going to give you this. Okay? And so that is going to be, which answer is that going to be here? That's going to be C. Okay? So your answer for number 10 is C. And that was all the calculator inactive questions. Okay? Thank you, guys. And I'm going to go back and do that other problem in the video. I done kind of ran out of time. All right. If you need to slow it down, all you have to do is just pause the video and play it back again. If you have questions about something that I've done, please just ask me and I can just show you those things again, okay? All right.